Welcome students. Now, in the last class we discussed about the continuity of a function at a given point. That means whenever we have left hand side is equal to the right hand side, then we say that the function is continuous. Now, we shall solve some more problems very similar to the last problem. Now look at it. It is given that the function is uh, f of x equals 2x square minus 1 at x is equal to 3. Now we verify that, as usual we verify that limit we verify that the limit left hand side, that is limit of f of x extends to extends to 3. This is not minus 3, this extends to 3, that is equal to limit of 2x square minus 1 extends to 3. In the place of x you write 3, that is 2 into 3 square, that is 2 into 9, that is 18 minus 1, that is 17. Right hand side, that is it is f of 3 here. So what is f of 3? We all know that the f of x is 2x square minus 1. F of 3 is in the place of x, you write 3 here. Similarly, in the place of x also you have to write, that is 3. So what we get here? F of 3 is 2 into, this is x, 3 square minus 1. What is 3 square? 9. 9 into 2, 18 minus 1, 17. So we see that the left hand side, that is limit of f of x extends to minus 3. This value is 17, and the right hand side is f of 3. That value is also 17. We see that the function is continuous at x is equal to 3. Come to the next problem here. Examine the continuity of the function f of x equals x square minus sin x plus 5 at x equals pi. Similarly, we have that same definition, that is limit f of x extends to pi must be equal to f of pi. What is the left hand side? Limit f of x extends to pi. So what is extends to pi here? That is f of x value is nothing but, here we see that f of x is x square minus sin x plus 5. So it is in the place of x you write pi here, that is pi square minus sin pi plus 5. We know that the pi is nothing but 180 degree, isn't it? So what is the value of sin 180 degree? We know that sin 180 degree is 0. Therefore it is pi square minus 0 plus 5. That is the left hand side. In the right hand side, it is f of pi. In the place of x, you write pi here. Again, pi square minus sin pi plus 5. So what is this pi square minus sin pi plus 5? Sin pi value is, we see it is 0. So it is pi square minus 0 plus 5. It is pi square plus 5. So LHS is equal to the RHS. The function is continuous at x is equal to, it is not x is equal to 3 here, this is x is equal to what? X is equal to pi. Come to the next problem. Examine the continuity of the functions. Now look at these functions. These problems are little bit different from the other problems. Whether at any point is given here, examine the continuity of the following function f of x equals, first one is x minus 5 at, whether it is given at 5, at 2, at 3, nothing is given here. It is just given that you discuss the continuity of the function f of x equals x minus 5. How to discuss? That means it is not given at any point. That means we have to discuss f of x equals x minus 5 continuous at any point. We have to discuss, right? How to take any point here? In the last problems, we see that it is given that it is at, look at here, it is given that it is x is equal to pi, x is equal to 3. Here, as the point is not mentioned, we should take any point, that is any point as C. C is any point which belongs to the real number. So we proved that the function f of x is equal to x minus 5 is continuous for any real value of c. So how to prove this one? To prove this one, first we take, let's look at it. Let C be any real number in the domain of f. We had write down this. What is this C? C is any real number in the domain of f. We verify that as usual, we verify that limit f of x extends to c equals f of c. In the last problems, we see that at x equals 5, we have to check that it is at x extends to 5 equals f of 5. Since it is not given that, we have to consider an arbitrary point, that is, let C be any point in the domain of f. We have to prove that this is left hand side, this left hand side must be equal to the right hand side. So how to prove this one? Let us consider the left hand side. Limit f of x extends to c is, we know that the value of f of x is x minus 5, x tends to c. So in the place of x you write c, it becomes c minus 5. So what is f of c? This is the right hand side. F of c is, in the place of x, look at it, in the place of x you write c here, it is also c minus 5. So the left hand side is equal to right hand side. Therefore, the function is continuous for all values of x in the real line. Very similar to the last problem. Discuss the continuity of the function f of x equals 1 by x minus 5, where x is not equal to 5. We know that when x is 5, it becomes 1 by 0, which is not defined. So similarly, we take C be any real number in the domain of f. That means whatever you take the number, that is always in the domain of f. Now we verify that as usual, limit f of x extends to c equals f of c. So if we consider this left hand side, this is the left hand side. If we consider this left hand side, in the place of x we write 1 by x minus 5. So it becomes 1 by c minus 5. Right hand side is also 1 by c minus 5. So LHS is equal to the RHS. Therefore, we conclude that the function is continuous for all values of x except at x is equal to 5, because at x is equal to 5 the function is not defined. So now solve this as a homework. That is, you take this as a homework. What is that problem? Very similar way. F of x is equal to x square minus 25 divided by x plus 5, where x not equal to minus 5. Similarly, you solve this problem. Very similar to the last two problems. And also you solve this problem also, that is seventh one. What is that? Discuss the continuity of the function f of x equals x cube plus x square minus 1. Now look at a very similar way. You take CB any real number in the domain of f and you prove that left hand side is the same as right hand side. Okay, solve these two problems. Now look at that, one more problem is given here. What is that? Discuss the continuity of the function f defined by f of x equals 1 by x. Look at here, where x not equal to 0. X not equal to 0, why? Because it becomes 1 by 0. 1 by 0 is not defined. Now let us take, like similarly we take, let's see be any real number in the domain of f. We verify that limit f of x extends to c equals f of c. Now you consider the left hand side. What is left hand side? It is limit f of x extends to c. So limit f of x extends to c, in the place of f of x we write 1 by x. That is, so limit of 1 by x extends to c means 1 by c. That means in the place of x you write 1 by c. Right hand side f of c is also 1 by c. Therefore, LHS is equal to RHS. Therefore, what you say? Remember, the conclusion is, here we see that we have to write here f of x equals 1 by x is continuous. Continuous for all x not equal to 0. That is a very important. Remember, finally we have to write f of x equals 1 by x is continuous for all x not equal to 0. Now look at here. This is an important one. What happens when x is equal to 0? Now look at here. We see that at x equals 0, we can verify it. Look at here. At x equals 0. Now let us take the left hand limit and right hand limit at x equals 0. That means, what do you mean by x is at x equals 0? We should take, now let us take the left hand side. We verify that the limit of f of x extends to 0 minus is equal to limit of f of x extends to 0 plus, that is equal to f of 0. Then we say f of x is continuous at x equals 0. Now simply look, let us take limit f of x extends to 0 minus. What is mean by extends to 0 minus? It is mean that x is not equal to 0. But is the values of x is very nearer to 0, but they are less than 0. Right? So in the place of x, you write 1 by x extends to 0 minus. By definition of the left hand limit, wherever x is there, you replace by 0 minus h and make h tends to 0. That means we know the definition of limit, left hand limit, that is limit f of x, x tends to a minus means it is nothing but limit f of x is replaced by a minus h and make h tends to 0. This is actually the definition here. So that means in the place of, look at here, x tends to a minus. In the place of a you have 0, 0 minus. So therefore replace x by 0 minus h, h tends to 0. What is 1 by 0 minus h? It is minus 1 by h, right? What happens when h tends to 0 here? Now look at here. Whenever h is very close to 0, remember limit of 1 by h. When h is very close to 0, this quantity becomes a very large quantity. This will be an approximately equal to plus infinity, because if you take h is equal to very large, h tends to 0 means if you take h is equal to say 0.0001, then what is the value of 1 by h? It is 1 by 0.0001. What is 1 by 0.0001? It is nothing but 1 divided by 1 by what? 1, 2, 3, 4. 1 followed by 1, 2, 3, 4 0. This goes to the numerator. It becomes 3, 4. So is it a big number, isn't it? That means when the value of h is very nearer to 0, 1 by h becomes very large. So it is minus 1 by h is there. It becomes very small. That becomes it is minus infinity. If you consider the right hand limit here, x tends to 0 plus means here you replace this x by 0 plus h and h tends to 0. It becomes 1 by h, h tends to 0. As we see, this is plus infinity. What is left hand limit? Minus infinity. What is right hand limit? Plus infinity. So these two are not equal. So left hand limit is not equal to right hand limit. Therefore f is not continuous at x equals 0. Here we already know it is not continuous because f of 0 is not defined. Even though we can define this one, what is, that is left hand limit can be defined, right hand limit can be defined here, because this is x tends to 0 minus means this is x is not actually 0 here. Therefore we can define this quantity and the value will be minus infinity, this will be plus infinity. Therefore here we see the concept, that is always remember that 1 by 0 is not defined. Remember what is 1 by 0? 1 by 0 is not defined. But can we define this one? Limit of 1 by h. H tends to 0 is defined. Limit of 1 by h tends to 0, that is infinity, right? 1 by 0 is not infinity. Remember, 1 by 0 is not infinity, but look at here. What is that? This is limit of 1 by h as h tends to 0. That is here, limit of 1 by h tends to 0 is infinity. So we see one concept of why we defined how we can define the infinity, right? Whenever if you have 1 by 0, don't say it is infinity. Whenever if you apply the limit here, we can say it is infinity, right? Now come to the special kinds of problems here. Now look at this one. Discuss the continuity of the function f of x is 1 when x is less than or equal to 0, right? And it is 2 when x is greater than 0. Whether we have to check this is continuous or not at x equals 0, right? How to check it is whether it is continuous at x equals 0 or not? Now look at here. It is given that the function is defined for all values of x, right? Because 1 is well defined, 2 is well defined. Now we shall check at x equals 0, right? Now look at here. Uh, Here it is given that it takes the value 1 for all the values x less than or equal to 0. Remember it. Less than or equal to 0 means f of x takes two different values, 1 as well as 2 for two different values of x. That is why for less than 0, for greater than 0, so we must consider the left hand limit and right hand limit at 0. That is important. ನೋಡಿ ಇಲ್ಲಿ ಯಾವಾಗ ಲೆಸ್ ದ್ಯಾನ್ 0 ಗ್ರೇಟರ್ ದ್ಯಾನ್ 0 ಅಂತ ಈ ತರ ಫಂಕ್ಷನ್ಸ್ ಕೊಟ್ಟಾಗ ನಾವು ಕಂಪಲ್ಸರಿಲಿ ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಲಿಮಿಟ್ ತಗೊಳ್ಬೇಕು. ಯಾವ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಅಂತ ಕೇಳಿದಾಗ 0 ಅಲ್ಲಿ ಕೇಳಿದಾಗ ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಲಿಮಿಟ್ ಎಟ್ 0, ರೈಟ್ ಹ್ಯಾಂಡ್ ಲಿಮಿಟ್ ಎಟ್ 0, right? Now look at it. This is the left, that means limit f of x tends to 0 minus it is to, this is all left hand limit. This must be equal to, this is right hand limit, that must be equal to f of 0 in the definition ಹೇಳಿದ್ವಿ. That means continuityಗೆ ಇನ್ನೊಂದು ಡೆಫಿನಿಷನ್ ಇದೆ, ಏನಂದ್ರೆ ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಲಿಮಿಟ್ ಮಸ್ಟ್ ಬಿ ಈಕ್ವಲ್ ಟು ದಿ ರೈಟ್ ಹ್ಯಾಂಡ್ ಲಿಮಿಟ್ ದಟ್ ಮಸ್ಟ್ ಬಿ ಈಕ್ವಲ್ ಟು ದಿ f of 0, then it is continuous at x is equal to 0. Now let us take the left hand limit. Now limit, what is the left hand limit here? Limit of f of x tends to 0 minus. What do you mean by x tends to 0 minus? X tends to 0 minus means x is less than 0 ಅಂತ ಅರ್ಥ. X is less than 0. When x is less than 0, what is f of x? Look at this function again. X less than 0, the function is 1. So in the place of f of x, we write 1. So what is limit of 1? It is always 1. Because we already told you limit of any k is always equal to k. Whatever might be that x tends to any number k. Okay. So what is the right hand limit here? Limit f of x tends to 0 plus, 0 plus for the right hand limit. 0 minus means left hand limit at 0. Now look at here. What do you mean by x tends to 0 plus? X tends to 0 plus means it is clearly true that x is greater than 0. What is the value of the f of x when x is greater than 0? We have to look into this function here. X greater than 0, it is 2. So that is limit of, what is that? Limit of 2. Limit of 2 is 2. What is f of 0? Look at here. Less than 0 who 1, equal to 0 who 1 ಇದೆ. That means f of 0 is 1. Whether they are equal, look at here. Left hand limit is 1. Right hand limit is 2. Left hand limit is not equal to right hand limit. Therefore f of x is not continuous at x equals 0. Remember, even though the left hand limit is equal to f of 0, but these two are not equal. That is why f of x is not continuous at x equals 0. Now look at the one more. Now look at this function. It is just given that discuss the continuity of the function f of x equals x if x less than or equal to 1, if x greater than 1 at x equals 1. That means we have to check the function is continuous at x equals 1. Further, what about the continuity of f of x at what points? at say x equals 0, x equals 2, right? First we have to let us check the continuity at x equals 1. Now if you look into the entire function, the function is changing its values. ಯಾವ್ದೇನು ಚೇಂಜ್ ಆಗ್ತಿದೆ x ಮತ್ತೆ 5 ಸೇಮ್ ಇದೆಯೋ ಬೇರೆ ಬೇರೆ ಇದೆಯೋ ಇಲ್ಲಿ x ಇದೆ ಇಲ್ಲಿ 5 ಇದೆ x ಯಾವಾಗ x less than 1 as well as x equal to 1 5 whenever x is greater than 1. That means this function, what is the function? F of x is changing its value when x is equal to 1 ಅನ್ನೋ 1 ಅನ್ನೋ ಪಾಯಿಂಟ್ ಗೆ ಫಂಕ್ಷನ್ ಚೇಂಜ್ ಆಗ್ತಿದೆ. ಆ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ನೋಡಿ ಹೀಗಿರುತ್ತಲ್ವಾ. ಸೊ ಇಲ್ಲಿ ನೋಡಿ ಇದು 0 ಇದು 1 ಅಂತ ಇಟ್ಕೊಂಡ್ಬಿಡ್ತೀವಿ ನಾವು. ಒಂದಕ್ಕಿಂತ ಸ್ವಲ್ಪ ಕಡಿಮೆ ಇದ್ಬಿಟ್ರೆ ಎಫ್ ಆಫ್ ಎಕ್ಸ್ ಬೇರೆ ವ್ಯಾಲ್ಯೂ ತಗೊಳುತ್ತೆ, ಒಂದಕ್ಕಿಂತ ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ಇದ್ರೆ ಎಫ್ ಆಫ್ ಎಕ್ಸ್ ಬೇರೆ ತಗೊಳುತ್ತೆ. ಈ ಫಂಕ್ಷನ್ ಇಲ್ಲಿದೆಯಲ್ಲ ನಮ್ಮ ಫಂಕ್ಷನ್ ಎಫ್ ಆಫ್ ಎಕ್ಸ್ ಈ ಚೇಂಜ್ ಯಾವ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಚೇಂಜ್ ಆಗುತ್ತೆ ಅಂದ್ರೆ 1 ಅನ್ನೋ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಚೇಂಜ್ ಆಗ್ತಾ ಇದೆ ಅಲ್ವಾ. ಈಗ ನೋಡಿ ಅದಕ್ಕೆ ಗೊತ್ತಾಗದೆ ಹೇಗೆ ಅಂದ್ರೆ ಇಷ್ಟೇ ನಮ್ಗೆ ಕೊಟ್ಟಿರ್ತಾವೆ, ಇದನ್ನ ನೋಡ್ಕೋಬೇಕು. ಎಕ್ಸ್ ಲೆಸ್ ದನ್ ಆರ್ ಈಕ್ವಲ್ ಟು ಎಕ್ಸ್ ಲೆಸ್ ದನ್ ಆರ್ ಈಕ್ವಲ್ ಟು 1, ಎಕ್ಸ್ ಗ್ರೇಟರ್ ದನ್ ಆರ್ ಈಕ್ವಲ್ ಟು 1. Suppose if x less than or equal to 2, x greater than 2 ಕೊಟ್ರೆ changing at x equals 2 ಅಂತ ನೆನಪಡಿ. ಈಗ now let us look into the function now whether it is continuous or not. Look at it. Left hand limit f of x extends to 1 minus means it is always x less than 1. Limit of this is the right hand limit f of x extends to 1 plus means x is greater than 1. Everything must be equal to f of 1. Now let us take the left hand limit. That means limit of f of x extends to 1 minus, that is x less than 1. So which is the function whenever x is less than 1? F of x takes the value x when x is less than 1. So in the place of f of x you write x here, right? X tends to 1 minus means this is an attainable limit, right? Therefore you give the x value is equal to 1. That means this is equal to 1. ಇಲ್ಲಿ ನೋಡಿ x tends to 1 minus ಇದೆ ಅನ್ಕೊಂಡ್ಬಿಟ್ಟು ಇಲ್ಲಿ ನೀವು -1 ಕೊಡಬಾರದು, ಜ್ಞಾಪಕ. x tends to 1 ಇರೋದಿಲ್ಲಿ, ಆದ್ರೆ ಒಂದಕ್ಕಿಂತ ಕಡಿಮೆಯಿಂದ ಇದೆ, ಆದ್ರಿಂದ ಇಲ್ಲಿ ವ್ಯಾಲ್ಯೂ x ಗೆ 1 ಕೊಡಬೇಕು, ಜ್ಞಾಪಕ ಇಟ್ಕೋಬೇಕು. ತುಂಬಾ ಜನ ಏನ್ ಮಾಡ್ತಾರೆ ಗೊತ್ತಾ, x tends to 1 minus means -1 ಅಲ್ಲ, x tends to ಇಲ್ಲಿ -1 ಮೈನಸ್ ಕೊಟ್ರೆ -1 ಬರೀಬೇಕು. X tends to 1 minus ಅಂದ್ರೆ you give x is equal to 1, right? Now come to the right hand limit. Limit of f of x extends to 1 plus. 1 plus means what? X is greater than 1. Whenever x is greater than 1, f of x is 5. X is greater than 1. So limit of 5 ಏನಾಗುತ್ತೆ? That is equal to 5. Okay, limit ಬರಿಬೇಕಿತ್ತು. So what is f of 1? F of 1 means ನೋಡಿ, when x is equal to 1, f of 1 is 1, right? Therefore left hand limit is, what is the left hand limit? That is, we see that this is the left hand limit 1, this is the right hand limit, that is 5. So 1 is not equal to 5. F of x is not continuous at x equals 1, right? Now that is an important one. ಇದು ಸ್ವಲ್ಪ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಬೇಕು, ನೀವು ಚೆನ್ನಾಗಿ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ. at x equals 0 ಅಂತ ಕೊಟ್ಬಿಟ್ಟಿದಾರಲ್ವಾ, ಹಾಗಾದ್ರೆ ನೋಡಿ ಜ್ಞಾಪಕ ಇಟ್ಕೊಳ್ಳಿ, ಇಲ್ಲಿ in this case the function is changing only at x equals 1. It is not given x less than or equal to 0, x greater than 0, right? It is not changing, it is changing only at x equals 1, that's all. At x equals 0 what happens to this function? Can anybody guess? It is easy to guess here. Now look at here. Now we see here, look here. For x less than 1, f of x is x. Alva? Kotidaralva? X less than 1, f of x is x. At x equals 0, what is 0 here? Is this 0 less than 1 or greater than 1? Clearly this 0 is less than 1. Therefore, f of x takes the value x. For all at x equals 0, f of x will be x only. What is x here? X is a polynomial. Therefore, hence it is continuous at x equals 0. Every polynomial function is continuous. We already proved this result. It is every polynomial function is continuous. Therefore, we see that for all x less than 1, f of x is x. This is already we know. At x equals 0, it is clearly f of x is x. which is a polynomial, hence it is continuous. Now look at here. ಇನ್ನೊಂದು ಕೊಟ್ಟಿದ್ದಾರಲ್ವಾ, discuss at x equals 2 ಕೊಟ್ಟಿದ್ದಾರೆ ತಾನೆ ಇಲ್ಲಿ. It is given that it is at x equals 2. Now look at here. For x greater than 1, we see that whenever this x is greater than 1, f of x always takes the value 5. Therefore, at x equals 2, you know that this 2 is clearly greater than 1. F of x takes value 5. What is 5? 5 is a constant. Every constant function is continuous. We already know. We already proved every polynomial, every constant function is continuous. ನೋಡಿ ಹಿಂದೆ ಪ್ರೂವ್ ಮಾಡಿದ್ವಿ f of x equals k ಅಂತ ತಗೊಂಡು ಪ್ರೂವ್ ಮಾಡಿದ್ವಿ. So that is constant function is continuous. Hence it is continuous at x equals 2. ಜ್ಞಾಪಕಟ್ಕೊಳ್ಳಿ, ಇಲ್ಲಿ ತುಂಬಾ ಜನ ಕನ್ಫ್ಯೂಸ್ ಮಾಡ್ಕೊಂಡ್ಬಿಟ್ಟು ನೀವೇನ್ ಮಾಡ್ತೀರಾ, x equals 0 ಅಂದ್ರೆ ಲಿಮಿಟ್ f of x ಹಾಕೋತೀರಾ. ಲಿಮಿಟ್ f of x ಹಾಕೊಂಡ್ರು ಅದೇ ಆನ್ಸರ್ ಬರುತ್ತೆ. ಆದ್ರೆ ನಾವೇನ್ ಮಾಡ್ಬೇಕು, ಇಲ್ಲಿ ಯಾವ ವ್ಯಾಲ್ಯೂ ನಲ್ಲಿ ಚೇಂಜ್ ಆಗ್ತಾ ಇದೆ ಅನ್ನೋದನ್ನ ನಾವು ಗಮನಿಸಬೇಕು. ಆಯ್ತಾ? ನೋಡಿ ಇಲ್ಲೇ ನಾವು ಹೇಳ್ಬೋದು ಇದನ್ನ. ಇಲ್ಲಿ ನಾವೇನ್ ಹೇಳ್ತೀವಿ ಅಂದ್ರೆ, ಇಲ್ಲಿ ಏನ್ ಹೇಳಿದ್ವಿ, x less than or equal to 1, x greater than or equal to 1. We have to find left hand and right hand limit only for 1. ಒಂದಿಗೆ ಮಾತ್ರ ಚೆಕ್ ಮಾಡಬೇಕು. ನೀವು ಒಂದಕ್ಕಿಂತ ಬೇರೆ ಹೋಗ್ಬಿಟ್ರೆ ನೋಡಿ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇಫ್ ಯು ಟೇಕ್ x is equal to 100 ಅಲ್ಲಿ ಇದು ಕಂಟಿನ್ಯೂಸ್ ಚೆಕ್ ಮಾಡಿ ಅಂತ ಕೇಳಿದ್ರೆ ನಾವೇನ್ ಹೇಳ್ಬೇಕು, ಒಂದಿಗೆ ಮಾತ್ರ ಚೇಂಜ್ ಆಗ್ತಾ ಇದೆ. 100 ಏನಿದೆ ಆಕ್ಚುಲಿ, ವಿ ನೋ ದಟ್ ದಿಸ್ 100 is clearly greater than 1. 100 is greater than 1 ಆದ್ರಿಂದ ವಾಟ್ ಈಸ್ f of x? f of x is 5 because greater than 1 ಗೆ 5 ತಗೊಳುತ್ತೆ. 5 is a constant, it is continuous. At 100 it is continuous. If you take, I say x is equal to minus 20, clearly less than 1. So for all less than 1, f of x is x. Therefore we can write here f of x will be equal to x. X is a polynomial. Remember, x is a polynomial, hence it is always continuous. Every polynomial function is continuous. Now come to the next problem now. Discuss the continuity of the function f of x equals 1 if x not equal to 0, 2 if x equals 0. What is the speciality of this problem? It's a simple problem. Look at here. Here it is not given x less than or equal to 0, x greater than or equal greater than 0. So here we need not to go for left hand limit and right hand limit, not necessary. Left hand limit and right hand limit, not necessary. Not necessary, remember here. Now we have to check whether this is continuous at x equals 0. Now look at it. Here left hand limit and right hand limit not necessary. Now look at here. Here we verify that limit f of x extends to 0 equals f of 0. That's all. So now look at this. Meaning of what is extends to 0? Extends to 0 means x not equal to 0 anta. We all know that x is nearer to 0 but it is not 0. Now if you take the left hand side here, limit of f of x extends to 0, that means x not equal to 0. Whenever x is not equal to 0, f of x is 1. So limit of 1, that is equal to 1. And what is right hand side? Right hand side is, it is given that f of 0. Look at here, when x is 0, x is 0 means here, when x the value is 0, f of x takes the value 2. Therefore f of 0 is 2 here. Whether they are equal, left hand side is 1, right hand side is 2. Therefore left hand side is not equal to right hand side. F of x is not continuous at x equals 0. ಆಯ್ತಲ್ವಾ? For x not equal to 0, look at here, whenever x is not equal to 0, f of x is always 1, which is a constant. Since every constant function is continuous, therefore f of x is continuous for all except at x is equal to 0. X not equal to 0 bitre ella kade continuous agutte. If you take x is equal to 20, right? What is this 20? 20 is greater than 0. Hagare f of x enagutte? We know that f of x is 1. Sorry, f of x is 20. 20 is not equal to 0. F of x is 1. 1 is a constant, it is continuous. Right? But at 0, it is not continuous. But it is continuous at all other values. Remember it. That means if we just write the graph of this one here, It's simply like this. Look at here. F of x is, whenever it is not equal to 0, it is 1. That means for all values, but means for negative values, positive values, for all values it is 1. It takes the value 1. For all negative values, it takes the value 1. Whenever x is, it is like this, it is a gap here. Whenever it takes the value 0, it goes to 2 here. It goes to 2 here. So therefore, is it continuous here? For x greater, for all values x greater than 1 also it is continuous. Look at here. Is it continuous function? We have to draw here. ಹೀಗೆ ಬಂದ್ಬಿಟ್ಟು ಇಲ್ಲೊಂದು ಗ್ಯಾಪ್ ಬಂದ್ಬಿಡ್ತಿಲ್ಲಿ, ಮತ್ತೆ ಇಲ್ಲಿಗೆ ಹೋಗ್ಬಿಡತ್ತೆ, ಮತ್ತೆ ಇಲ್ಲಿಂದ ನೆಕ್ಸ್ಟ್ ಕಂಟಿನ್ಯೂ ಆಗ್ತಾ ಇದೆ. ಹೌದಾ? ಸೊ ಇದು ಕಂಟಿನ್ಯೂಸ್ ಆಗಿಲ್ಲ. ಕಂಟಿನ್ಯೂಸ್ ಆಗಬೇಕು ಅಂದ್ರೆ ಸ್ಟ್ರೈಟ್ ಹೋಗಬೇಕು. ಇಲ್ಲಿ ಯಾವ್ಯಾವ ನೆಗೆಟಿವ್ ವ್ಯಾಲ್ಯೂಸ್ ಬೇಕಾದ್ರೆ ತಗೊಳ್ಳಿ. -1 ಕೊಟ್ಟರು 1 ಇರುತ್ತೆ. ಇಫ್ ಯು ಟೇಕ್ -2 then it is 1, because these -1 -2 are not equal to 0. It is 1. For 0 it goes to 2. For here it is, when it is 1 it comes to again it is 1. Therefore the function is not continuous here. It is not continuous at which point? It is not continuous at only this point, that is at x equals 0. For all x less than 0 continuous, for all x greater than 0 continuous. Now look at it. Discuss the continuity for the function f of x equals x cube plus 3, x not equal to 0, x equals 0. Now look at it. We have to check at x equals 0 only, isn't it? Because left hand limit is, right hand limit is not given. Left hand limit, right hand limit ಕೊಡಬೇಕಾದ್ರೆ x less than 0, x greater than or equal to 0 ಕೊಡಬೇಕು. Now we just verify that the limit of the function f of x extends to 0 is equal to f of 0. So this side is left hand side and right hand side is f of 0, right? So let us take the left hand side now. X tends to 0. Always remember, in this case x tends to 0 means x not equal to 0 ಅಂತ ಅರ್ಥ. X not equal to 0 means f of x value is equal to x cube plus 3. So in the place of right it is x cube plus 3. What is limit of x cube plus 3? Attainable limit. You put the value of x is equal to 0. 0 plus 3, that is equal to 3. And what is the right hand side? Right hand side is f of 0. Right, look at here. At 0 it is 3. So f of 0 is 3. What is the left hand side? Left hand side is 3. Right hand side is also 3. What do you say? F of x is continuous at x equals to 0. We checked only for x equals 0. For all x, look at here. For all x, x ಬರಬೇಕು. For all x not equal to 0, f of x ಏನಾಗುತ್ತೆ? x cube plus 3 ಅಲ್ವಾ? What is x cube plus 3? Remember, x cube plus 3 is a polynomial, which is a polynomial. Hence, it is always continuous. Okay. Students, ಆ ಎರಡು ಹೋಮ್ವರ್ಕ್ ಗಳನ್ನ ಮಾಡಿ ಇದನ್ನ ಚೆನ್ನಾಗಿ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ. ನೆಕ್ಸ್ಟ್ ಫರ್ದರ್ ಇದೇ ತರದ ಫಂಕ್ಷನ್ಸ್ ಬರುತ್ತೆ. ನಾವು ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಲಿಮಿಟ್, ರೈಟ್ ಹ್ಯಾಂಡ್ ಲಿಮಿಟ್ ಎಲ್ಲಿ ಅಪ್ಲೈ ಮಾಡಬೇಕು, ಎಲ್ಲಿ ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಲಿಮಿಟ್ ಅಪ್ಲೈ ಮಾಡೋದು ಬೇಡ ಅನ್ನೋದನ್ನ ನೀವು ಪರ್ಫೆಕ್ಟ್ ಆಗಿ ತಿಳ್ಕೊಂಡ್ರೆ ನಾವೆಲ್ಲಾ ಪ್ರಾಬ್ಲಮ್ಗಳನ್ನ ಸಾಲ್ವ್ ಮಾಡ್ಕೋತಾ ಹೋಗೋದು. ಇಲ್ಲಿ 4 ಮಾರ್ಕಿನ ಒಂದು ಕ್ವಶನ್ ಪೇಪರ್ ನಲ್ಲಿ ಇರುತ್ತೆ. ಮತ್ತೆ ಈಸಿಯೆಸ್ಟ್ ಕ್ವಶನ್ ಇರುತ್ತೆ. ಫಿಕ್ಸೆಡ್ ಕ್ವಶನ್ಸ್ ಗಳಿರ್ತವೆ. 99% ಎಲ್ಲಾ ಸ್ಟೂಡೆಂಟ್ಸ್ 4 ಮಾರ್ಕ್ ಬಂದೇ ಬರುತ್ತೆ. ಈಸಿ ಪ್ರಾಬ್ಲಮ್ಸ್ ಇರ್ತವೆ. ನಾವು ಮಾಡೋ ಪ್ರಾಬ್ಲಮ್ಗಳೆಲ್ಲವೂ ಈಸಿ ಇರ್ತವೆ. ಆದ್ರಿಂದ ಇದನ್ನ ನಿಧಾನವಾಗಿ ಕಲಿತ್ಕೋತಾ ಹೋಗೋಣ. ಓಕೆ, ಥ್ಯಾಂಕ್ ಯು ವೆರಿ ಮಚ್.